Okay, so question number 10 on your circular motion worksheet. First, it tells us the curve is perfectly banked for 16.6 meters per second, or a speed of 60 kilometers per hour. So we start without any friction then, and we do the sum of the forces in the y direction. This car is not moving in the y direction. So Fny minus Fg should equal 0. So Fn, here's my theta, so Fn cos theta should equal mg. Always in the y direction, you're trying to solve to get an expression for Fn, so it'll be mg over cos theta. Then you go to sum of the forces in the x direction, and that's what's applying the centripetal force, so mv squared over r. With no friction, the only force in the x direction is Fnx, and Fnx is really Fn sine theta is equal to mv squared over r. Where Fn is, plug in this. So mg sine theta over cos theta is equal to mv squared over r. The m's cancel. This becomes g tan theta is equal to v squared over r. So tan theta is equal to v squared over gr. We found the v to be 16.6, repeating, meters per second squared over 9.81 meters per second squared, and they had told us that the radius was 70 meters. Okay, don't forget to square your speed divided by 9.81 and by 70. Take the inverse tan, and you should get an angle of 22.0239, let's say, degrees. And you can always store that, if you have a memory, so that you don't, in your calculator, I mean, not in your head, so that you don't lose it. Okay, now we're going to add friction in. Now we want to go faster, and if we want to go faster, we're going to need friction to help us. So friction acts this way along the curve, and so it'll have an x component acting into the center of the circle and a y component acting down. Because it has a y component, we now have to start it back again with some of the forces in the y. Still not moving in the y, but now it's Fny minus Fg and also minus friction in the y. Fny is still Fn cos theta. Fg is mg, and in the y component, it's Fn, or F friction, it's going to be sine. So friction sine theta. Okay, we're trying to solve for Fn, but you need to realize that friction has an Fn in it. So it's really going to be Fn cos theta minus mu Fn sine theta. And we're going to take the mg over to the other side because it doesn't have an Fn in it. Now you can factor out the Fn. Cos theta minus mu sine theta is equal to mg, and then divide by the brackets. So this time your expression for Fn is mg divided by cos theta minus mu sine theta. Okay, so now we can go to the x direction. Sum of the forces in the x direction should be equal to mv squared over r. In the x direction, we have Fnx and friction. So Fnx plus friction in the x direction, of course, is equal to mv squared over r. Fnx is really Fn sine theta, and friction is really, and they're both positive because they're both going towards the center. Friction is really mu Fn, and the x component is cos theta, is equal to mv squared over r. So now we're getting ready to sub our Fn in, but I would highly recommend pulling the Fn out in front here first before subbing in for it, because otherwise you're going to end up subbing in twice. It's not the most streamlined, prettiest thing in the world to sub in, so subbing in once will probably be enough. Okay, so pull the Fn out and now sub in for it. So mg, and staying on the top, is your sine theta plus mu cos theta. And then the bottom of the Fn, cos theta minus mu sine theta. And that's going to be equal to mv squared over r. The m's will cancel, which is a great thing. Doesn't matter my mass if I want to go around a curve. And I'm trying to solve for mu, and right now the mu's are stuck inside the brackets. So I'm going to need to get them out of the bracket. And so to do that, I would probably cross multiply. So it'll become gr brackets sine theta plus mu cos theta equal to, the m is gone, so v squared brackets cos theta minus mu sine theta. Now multiply through the brackets. So gr sine theta plus mu gr cos theta equals v squared cos theta minus mu v squared sine theta. Trying to solve for mu's, and there's two of them, so take them to the same side. I'd probably bring my negative mu over here. So I would have mu gr cos theta plus mu v squared sine theta is equal to v squared cos theta minus gr sine theta. Now pull the mu out, so gr cos theta plus v squared sine theta in brackets, and this side doesn't change. You can probably see that there is a multitude of places just waiting for you to mess up: a negative, a squared, a cos, a g. Divide both sides by the bracket. So v squared cos theta minus gr sine theta divided by gr cos theta plus v squared sine theta. And now fill in your numbers. Now, when you go to fill in for the speed, remember you have to use the second one. If you screw up and forget and put the 16.6 in, you'll get a mu that's really close to 0, because that was for when you didn't need friction. Okay, so this will be 25 meters per second squared, cos of, what was it, 22.02, etc., minus 9.81 meters per second squared. The r was 70 meters, sine of the 22.02, etc., divided by 9.81 meters per second squared times 70 meters times the cos of 22.02 plus 25 meters per second squared times the sine of 22.02. I am trusting that you can see that there are a whole multitude of places that you can screw up here. Okay, if you do the top first, you should get something like 321.885, and that'll be meters squared per second squared. And the bottom will be something like 870.96, also meters squared per second squared. And when you divide them out, you should get 0.3696. Okay, so I'm just telling you the top and bottom there for when you have, when you're not getting the right answer. It might help you figure out which spot you messed up in. Okay, so there it is, your first banked curve with friction. But it won't be your last, because there's more. Woohoo! Aren't you excited?